Let's talk about factoring polynomials. So the first type of factoring we want to talk about is factoring out the GCF. GCF stands for greatest common factor. So let's break down those three words. Greatest means the largest or the most. So we need to keep that in mind when we're looking for the greatest common factor, that we take out of our polynomial the most that we can to make sure it's completely factored. The common factor means that all terms of the polynomial have the factor we're talking about. They all have it in common. And then factor means that it's going to be a number, might be a variable, or a term, like a number with a variable that divides evenly into a term of our polynomial. Keep in mind that using the distributive property, and sometimes they call factoring GCF is factoring by the distributive property, so they mean the same thing. But you can use the distributive property when you're finished to check your work. You just distribute the greatest common factor to see if you get back the polynomial that you started with. Let's try some examples. So follow with me. Example 1 is 15w plus 21. So if we come over here and break up 15w, what would give me 15? We know 1 times 15 is 15, and 3 times 5 is 15. So let's see what it might have in common with 21. 21 comes from 1 times 21, 3 times 7, and that's it. So we look and see what would be the greatest term that they would have in common, the greatest factor. So I see they both have 3 is the largest number because we want to take out the most that we can, but then 15 has w, but 21 does not, so they don't have w in common. So we could use this step right here to help us write out the answer. So I have a 3, that's what I'm going to take out, and what's left over will be the 5 that I did not circle, but 3 times 5 would give me back 15. And I can't forget the w that was up there. And then 3 times 7 would give me back 21. So I need to put plus 7. But 21 didn't have any variables, so we just put the 7. So then we could check our answer. 3 times 5w would give me back 15w. And 3 times 7 would give me back 21. So it's good to just check your work and make sure you got the right factors. Let's look at example 2. So if I write down 6 and then a squared is a times a, and let's put minus 8a, and then we'll look at the 6 and the 8. 6 would come from 1 times 6 and 2 times 3. Those are the only factors of 6. And then 8 comes from 1 times 8 and 2 times 4. So we look for our greatest number, which would be 2, but this time they do both have a letter in common. They both have one a, but 8 doesn't have another a, so I can't take out 2 a's, but I could take out 1. So we take out the 2a and write that out front, and what's left over is easy to find over here. I've got 3a that I did not circle, minus 4. But I circled a, so that's already out front. So I just need to write minus 4. And then I need to check my answer using the distributive property. 2a times 3a would give me back 6a squared, and 2a times negative 4 would give me back negative 8a. So now I have factored that binomial. Let's look at the next example. So even with a larger polynomial, we can use the same procedure if this is helpful. So we look at 9x cubed. I'm going to write 9 and then x times x times x, so I can spread them out. That way I could circle them. Minus 6, and then x squared is x times x, plus 12, and that one just has an x. Then we could write out our factors. We got 1 times 9 gives us 9. And 3 times 3 gives us 9. Then we look at 6. 1 times 6 gives me 6, and 2 times 3 gives me 6. 12 comes from 1 times 12, 2 times 6, 3 times 4. So we look and see what would be the greatest number that these three numbers have in common, because remember they all have to have the same number in common. So it looks like they all have a 3. So I can circle the 3's. And then they all have one x. Notice this 12 only has one x, so you're only going to be able to circle one of them. So it's sometimes easiest to start with the number that has the least amount of variables, because it's sort of like your limiting term. You're not going to be able to take out more than the smallest one has. And so then we can write our answer by putting together the 3x that everything has in common out front, and then we write what's left from each term. So here it's easy to see I have 3 and I have 2 x's left. So I write 3x squared. I have minus 2x left over here. So make sure you put minus 2x all together. And then I have plus 4. But I don't have any x's left because I took the 1x out. And then we can check our answer using distributive property again. 3x times 3x squared would give me back 9x cubed. Remember, with your exponent rules, the 1 plus the 2 would give you back 3 x's. 3x times negative 2x would give you back negative 6x squared. And 3x times 4 would give you back 12x. Let's look at this last example. So this one has 3 terms again and has several p's, so let's write it out. We have 6, and then there are 6 p's, so we can write them out. Just takes a second. Plus 24, and then 24 has 5 p's, and 18 has 3 p's. But that way we can see everything we have and what's left over. Nice and simple. So 6 comes from 1 times 6 and 2 times 3. 24, we've got to list 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And 18, we've got 1 times 18, 2 times 9, 3 times 6. So we look and see what would be the largest number that these three numbers have in common. So looks like 6 would be the largest number. And it's helpful to look at the shortest list that you have. See how these lists are longer? This one is the shortest. 6 would be the largest number I could take out here. So if both of these terms have a 6, then that's going to be the number that they have in common. That's my greatest number. Then again, look at the term that has the smallest number of variables and start there. 18 has 3 p's, and so does the first term and the second term. So that's all I'm going to be able to take out since 18 only had 3 to start with. And then we could write the answer. So each one of our terms had 6 and 3 p's in common. So we have 6p cubed. What's left over is what is right beside it. So we got 1, and then there's 3 p's. So you don't have to write the 1. We could just put p cubed plus 4 and 2 p's left over. So plus 4p squared. So notice it's important to write neatly so you could read what you wrote, especially here on this middle term. And over here we have plus 3, but we took out all of our letters, so we just have plus 3. And then we're going to check our answer again. 6p cubed times p cubed would give us back 6p to the 6th power, because we would add our exponents on the p's. 6p cubed times 4p squared would give us back 24p to the 5th, again adding the exponents. And 6p cubed times 3 will give us back 18p cubed.